we will prove these problems. We have two problems. The first is show that if q1, q2 until qn are primes, there is a prime q not element in q1, q2 until qn. And the number 2, let p equals to 2, p2 equals to 3, p3 equals to 5, and any other, and in general, p1 equals to the first prime. Prove or disprove that p1, p2 until pn plus 1 is prime for all n greater than or equals to 1. Let's prove the first problems. Number 1, we can start. Take any and in integers number we have q1, q2 until qn in p. P in here is primes number. And p in integers number. So n equals to q1, q2 until qn. Based on the lemma 2 that say if n greater than 1, there is a prime q such that q divides n. And based on the definition, of divisibility algorithm, then we get n equals to q times m for some m, and m in integers number. Not that there is a prime q not element in q1, q2 until qn. Since n equals to q1, q2 until qn, so we can conclude that if q1, q2 until qn are prime, there is a prime q not in q1, q2 until qn. So that's all for prove these problems. And then we have to prove the second problems. Let p1, p2 until pn plus 1 is a Euclidean numbers. Then the first 5 Euclidean numbers is for n equals to 1, then 2 plus 1 equals to 3, and for n equals to 2, then there exists 2 times 3 plus 1 equals to 7. We can get this from the primes number, and for n equals to 3, then 2 times 3 times 5 plus 1 equals to 31, and for n equals to 4, then 2 times 3 times 5 times 7 plus 1 equals to 211. For n equal to 5, then 2 times 3 times 5 times 7 times 11 plus 1 equals to 2,311. We know that this form is prime number. They are all prime number. But for n equals to 6, then 2 times 3 times 5 times 7 times 11 times 13 plus 1 equals to 30,031. We know that this form is not prime. 30,031 is not prime. It's not a prime number because 30,031 equals to 59 times 509. So 30,031 have another factor. For n equals to 7, then 2 times 3 times 5 times 7 times 11 times 13 times 17 plus 1 equals to 510, 511. We know that this is equals to 19 times 97 times 277. So it's not prime number because it's have another factor except 1 and its number. There are 19, 97 and 277. So we can conclude that the statement P1, P2 until Pn plus 1 is prime for all n greater than or equals to 1 is not true. Thus, that is this proof. So that's all for proof